Hello and welcome to our first project in atmospheric science using Python. In this tutorial, we will download our data, more precise the CPC precipitation, fix the not available data to none. I'll explain this in a bit. We will calculate the seasonal average. I'll show you for winter and I leave the rest to you. And finally, we will plot the result using Basemap library. Without any hesitation, let's jump back to Python. Okay, back to Python. We'll continue by creating a new folder. I'll name my netcdf analysis. It will contain our netcdf file, also our Python script. Let's continue with the download of our data. Open your favorite browser and in the search bar just type CPC precipitation. Open the first result. In your specifications, we can see the temporal coverage, the spatial coverage, the levels, the update schedule, the dataset formatted size, netcdf4, and finally the missing data, which is flagged with a value of approximately 10 times 10 to the power of 36. On your variable section, go to the last precipitations, total, surface daily, press the second button, download files, and go to your download page. Just scroll down and download the second last one, which contains the daily average precipitation from 1991 to 2020. I'll continue the video after download. Okay, back to Python. Inside the folder we created previously, we have imported the netcdf file. Also, we created a new Python script called winter precipitation, as we're gonna calculate only the seasonal precipitation for winter. Inside the Python script, we have imported 4 libraries, numpy as np, as we're gonna work with numpy arrays, netcdf4 as nc to read our netcdf file, matplotlib to plot our data, and finally Basemap library to create our map. Let's now create a new variable called path equal to the path of our netcdf file. It is in the same folder, so we don't have to add the whole path. Now create a new variable called nc file equal to nc.dataset, our path, the netcdf file, also in read mode. And finally, let's print the nc file.variables. Run our script. Down the terminal, we can see all the variables inside the netcdf file, latitude, longitude, time. Also the variable that we are interested in, precip, time, latitude, longitude, which stands for precipitation, and its missing values are minus 9.96 times 10 to the power of 36. Let's now see how we can change this missing value to np.none so that we can calculate the average data without any errors. First, we're gonna see an example. Let's create a new Scratch file, Python. Let's name it mask test. Let's import numpy as np. Create an array containing the elements 3, np.none, 0 and 1. Let's print the x array, run our script. Let's now use a logical term inside the print function. Print x is equal to 3, run our script. We can see that the result is an array containing only logical terms, true or false, whenever the condition is true or not. Back to our script. Let's print x is equal to np.none. Run our script. We can see that the result is an array containing only false, which is not correct. The second element is none. To fix this issue, we're gonna use inside the print function the np dot is none. Inside the parentheses, we give the x array. Run our script again. We can see that the result is an array again, but the second element is true, which is total correct. Now let's use the same method to change the values of the elements inside the x array. For this, we're going to use x, np dot is none, again the x array equal to 5. Let's print again the x array, run our script. Now we can see that the second element has changed from none to 5. Again, x equal to 5. Let's change it back to np.none. Let's print again the x array. Run our script. Now we have changed the second element back to none. Let's go back to our winter precipitation script so that we're gonna use the same methods to change the missing values to np.none. Let's close the mask script, also minimize this one. Run again the winter precipitation. Now we have to read the data from the netcdf file and store them to variables. First, we're gonna create the lat variable equal to nc file dot variables lat, and we're gonna get all the elements and turn them to an array. For this, np.array. The same will be done also for longitude. And finally, for the variable that we are interested in, precipitation, it is called precip. And finally, let's print precipitation.mean. Run our script. The mean value is minus 9.96 times 10 to the power of 36, and this is the value we have to change to np.none. Let's minimize our terminal. Back to our script. Precipitation, bracket, again precipitation equal to minus 9.90 equal to np.none. Again, let's print the mean of precipitation, and now let's print also the max value. Run again our script. Our max and mean values are np.none. Our precipitation variable is a 3D array with the dimensions of time, latitude and longitude. The time dimension is a 365 total elements, starting from 0 the 1st of January until the 364, which is the 31st of December. To calculate the seasonal precipitation of winter, we have to calculate the January, February and December. To do this, we're gonna create a new variable called x is equal to np dot linspace 0 to 58, a total of 59 elements. It is January and February. The second variable y equal to np dot clean space 365 minus 31 to 364. 31 of December is 364 because we start from 0. 31 days. Let's print X and Y. Run our script. Let's now append those two arrays. For this, we're going to create a t variable equal to np.append X and Y. Let's print t variable. Delete this command. Run our script. Everything seems fine. Create an array called winter precipitation. It's gonna be equal to np.empty, and the shape gonna be length of t, first the time, second length of lat, and third length of lon. Now let's create a for loop for I, d in enumerate t. Let's first print I and d to see what I and d stands for. Okay, I stands for the index and d for the element. Winter precipitation, I, every latitude and every longitude is equal to precipitation, d, every latitude and every longitude. We have to change the d to integer. Let's run our script. Everything looks fine. Outside the for loop, let's print winter precipitation dot shape. Run again. Nice. Let's now create a new variable called winter seasonal total precipitation equal to np dot non-sum. We're gonna add all the daily average precipitations of winter precipitation, giving the axis 0. Let's now print winter seasonal total precipitation dot shape. Let's run our script. And everything looks fine. Let's minimize the terminal. Let's clear our script. We don't need this one. Also those two. Let's now continue with our data visualization. First, we're gonna create our map. Map is equal to Basemap. Map.draw coastlines. Then we're gonna use the matplotlib library to plot our data. plt.contourf. First we have our x-axis, longitude, then our y-axis, latitude, and then our data. Winter seasonal total precipitation. Okay, now let's use plt.show. Let's run our script. Okay, we have to correct our base map. Inside our base map, let's use low left corner, longitude equal to 0, low left corner of latitude minus 90, upper right corner of longitude 360, upper right corner of latitude 90. Let's run again. Let's visualize our data a little better. Close this one. Inside our contour f plot, just add cmap equal to z. Let's run again. Okay, nice. Let's add our color bar, plt.color bar. Run again. Also, let's give our plot a title, plt.title. I'll give mine winter total precipitation. Let's run again. That's all for this project. If you like this video, consider subscribing, give me a thumbs up, or in the comments down below any suggestion for a future project. Thank you for watching and see you in the next video.